application problems. These are always going to be word problems. So there are some steps I want you to follow. I want you to read the problem and I want you to read it carefully. I want you to assign variables and write those down. I want you to write an equation that links the variables um, to the problem. I want you to solve for the variable you're looking for, state the answer with correct units, and of course, always check. Now, you're going to need to make sure you discard any solution that doesn't satisfy the physical constraints of the problem. That's part of the checking. So you're not going to have negative times and that sort of thing. Suppose I have a box that has a volume of 7,500 centimeters cubed, and it's to be formed from a sheet of metal whose length is twice the width. Equal sized squares measuring 10 centimeters on a side are to be cut from the corners of the metal sheet in order to form the box. What are the dimensions of the original piece of metal? Now, the first thing you want to do is assign variables. If I let x be the width of the original rectangle, and then 2x is the length of the original rectangle. So we have the length and the width of the original rectangle. Now here's the original piece of metal, x by 2x. And the box is going to be formed by cutting 10 centimeters by 10 centimeters from both the length and the width. So that's these corners here. And if I fold it up, I can see what it's going to look like. Now, x minus 20 is going to be the width of the bottom of the box because I'm subtracting off 10 twice. Now, the length of the box is going to be what? 2x minus 20. And 10 is the height of the box. A diagram really helps you on these box problems. So the volume is length times width times height, which is 7,500 centimeters cubed. So 7,500 is 2x minus 20 times x minus 20 times 10. I want to FOIL this out, multiply this out, and then put my equation in standard form. And go on and divide through by 20. Simplify this as much as you can. So I have x squared minus 30x minus 175 is equal to 0. I can factor this one to get x plus 5 times x minus 35. And then use the 0 factor property. So x plus 5 is 0, or x minus 35 is 0. Solving these, I get x is negative 5, or x is 35. Now let's think about this. What was x? X was the length of one of the sides of a piece of metal. So can it be negative? Nope. So you have to throw out the negative 5 solution. So you get the dimensions of the metal, or x, when x is 35, the dimensions of the metal piece are 35 and 70. Now Pythagoras said that if you have a right triangle, then the sum of the squares of the legs is equal to the square of the hypotenuse. A squared plus b squared is c squared. So suppose you have a piece of property that's in the shape of a right triangle. The longer leg is 10 meters shorter than twice the length of the shorter leg, and the hypotenuse is 20 meters long than the longer leg. Find the lengths of the sides of the property. So let's just let x equal the length of the shorter leg. The length of the longer leg is 2x minus 10, and the length of the hypotenuse is, what, 20 more than the longer leg. So it's going to be 2x minus 10 plus 20. So the hypotenuse is 2x plus 10. So make sure you draw your picture. It always makes life a lot easier. Use Pythagoras' theorem. X squared plus 2x minus 10 squared is equal to 2x plus 10 squared. Multiply it out, collect like terms, and you get x squared minus 80x is equal to 0. I can factor this into x times x minus 80. So I get x is 0, or x is equal to 80. Now, since s represents the length of a side, then 0 is not a reasonable answer. So the lengths of the sides are 2 times 80 minus 10, or 150, and 2 times 80 plus 10, or 170. Now, projectile problems are always fun, but they can be a little confusing. In a projectile, basically what we're doing is we're firing something up and it's going up and it's coming back down. We're going to have to give you, or you're going to have to find V naught, which is always the initial speed or its initial velocity. It might be the muzzle velocity. S naught is the initial height. That's how high above the ground, and the ground is down here. High above the ground did you fire your shot? And S is your height at any time t. Now, what makes this kind of confusing is there are two different equations, depending on whether you're using feet or meters. So when you're using feet, we say that S is negative 16 t squared plus V naught t plus S naught. When we're using meters, S is negative 4.9 t squared plus V naught t plus S naught. See, the only thing that changes there is the coefficient of your squared term. The good news is I'm always going to tell you which of these two equations to use. So suppose I have a projectile shot upward from the ground with an initial velocity of 73.5 meters per second. Neglecting air resistance, its height is given by, see, I told you what the equation was. S is negative 4.9 t squared plus 73.5 t. After how many seconds will the projectile be 100 meters above the ground? So what I'm asking is find the time when S is equal. So I put in 100 for S, and I rewrite this in standard form. And I'm going to use a quadratic formula to find t. In this case, A is 4.9, B is negative 73.5, and C is 100. Plugging in and cranking through my algebra, I get 1.5 or 13.49. Both solutions are okay because the projectile passes 100 twice, once when it goes up and once when it comes down. So the projectile is going to be 100 meters above the ground after 1.5 seconds, and then after 13.49 seconds. So, well, it's above ground only between 1.51 and 13.49. How long will it take the projectile to reach the ground? What we're asking for then is when is F equal to 0. So I set 0 is equal to negative 4.9 t squared plus 73.5 t. In this case, I don't need to use quadratic formula. I can factor t out. And I can use a zero product that tells me t is 0. Or when negative 4.9 t plus 73.5 is 0. Solving that, I get t is 15. So it's going to take the projectile 15 seconds to return to the ground. Now, sometimes we're just going to give you a funky equation. So, suppose I tell you that based on the figures from the period 2000 to 2013, the quadratic equation models sales of new cars, where S represents the sales in millions, and X equals 0 represents the year 2000. X equals 1 represents 2001, etc. And I want you to use a model to determine the sales in 2013 and compare the results to the actual figures of 7.6 million. So we know S is this ugly equation, 0.538x squared minus 0.707x plus 8.84. And in 2013, X is equal to 13. So I'm going to substitute in 13 and multiply, and I get 7.4 million, because remember that my answer is given in millions. The actual figure was 7.6 million, so this is 0.2 million less than the actual figure. According to the model, in what year did the sales reach 5.9 million? Round down to the nearest year. So I'm going to want to know when is S equal to 5.9. Solve for X. So we're going to put it in standard form. And in these, you always want to use a quadratic formula. And I get 8.8 or 6.2. So according to the model, sales reached 5.9 million about 6.2 years after 2000, or in 2006. And in about 8.8 years after 2000 or in 2008. Now you remember they said round down to the nearest year. So we're going to round the 8.8 down to 8.